All right, listen, here's what I'm going to do, guys. I'm going to actually record this. It's actually recording my voice as we speak, and it'll record me drawing this as well. I'll go back and do this again, 5th period, and I'll try to have it uploaded to YouTube by the end of the day with the link on Canvas so you can actually go back and watch me do this. How's that sound? That worksheet that we went over in class, I'll do the same thing with the 5th period. So it'll be me going over the worksheet and drawing out the other stuff you need to know.
When is this?
Yeah, don't worry about the last question. Test is tomorrow.
So this test is tomorrow.
This test is tomorrow. All right, so guys, look at this. Let's say I've got an equation. Say I've got...
Where's number 7?
Don't worry about it.
Number 7 is 42 degrees Fahrenheit and 0 degrees Celsius.
Okay, so let's say I've got this equation, right? And we need to label the parts. So first off, what is this equation for? What is this called? Because you need to know that.
It's the neutralization.
Neutralizat. Reaction. So let's label the parts here. What is HCl going to be?
Hydrogen.
Let's just say that's the acid. NaOH is the...
Base.
What's the arrow?
It's a yield.
Okay, what's this next part?
It's product.
Water. And then this is what?
It's sodium.
Okay, so you got to remember the neutralization reaction is acid plus base yields salt plus water. Okay, acid, base, yields water plus salt. Sit down and turn around before I ask you to leave. Isaiah, slide the board back over just a little bit. Salt. NaCl. Keep going, keep going, keep going. Right there, that's good. All right, now, Maverick said something. This whole left side right here is called what? What do we call everything on the left side?
Opposite of product.
Those are the reactants, and everything over here is called products. There's a question almost identical to this on your test, where you have to label all the parts. All right. Like I said, I'm putting this on. It'll be on YouTube later.
YouTube.
Yeah, I'm gonna put a link of me going over this. I'm gonna explain everything on YouTube. All right. Next thing we gotta know. pH scale. So what's the pH scale go from?
0 to 14.
0, 14. What's in the middle?
7.
Okay, what substance is 7?
Water. Pure.
Pure water. Okay, we say that 7 is neutral. So from 0 to 7 are the 7 to 14 are the bases. All right, if we're talking about ion concentration, neutral is what? What's the ions at neutral? Hydrogen equals hydroxide. If it's an acid, it has a higher concentration of which one? Hydrogen is greater than hydroxide. And if it's a base, hydroxide is greater than hydrogen. What's another name for the hydrogen ion that I told y'all? You may hear it also called what? Hydronium. Okay, here's the equation for the dissociation of water. Okay, you need to remember that equation. Okay, so where's my strong acid? Where are my strong acids close to?
On the left side.
Closer to what number?
0.
And here are my weak ones. Here are my weak bases. Strong bases. Okay, if we're talking about the bonds, which one has the strong bonds?
The acids.
The weak acids or strong acids?
Weak acids.
Yeah.
It's the weak acids. They're trying to be more like water.
They want to be like water. So strong bonds are right here in the middle. Out here we have weak bonds because they do want to do what? They want to break into their ions. They want to be more like their ions. Okay, I'm trying to think anything else on acids and bases you need to know. Yes, Eli?
With the dissociation of water, the yield signs, they can go either way.
Very good. Did y'all hear what Eli said? Shh. Did y'all hear what Eli just said? In the dissociation of water, if you look at the yield sign, notice it's doing what? Goes in both directions. So what that tells us is that a water molecule will break down to its ions just as easily as the ions will join back together and form their water molecule. Okay, so here's what we've gone over. We've talked about a water molecule. We've talked about the neutralization reaction. And then we've talked about the pH scale. Anything else that you can think of that you may need to know for this test? Lindsay, get off your geography. Any questions? All right, guys, so look, I'm going to make a deal with y'all. Okay, so we're reviewing for your test on properties of water and acids and bases tomorrow. So let's go through the review worksheet that was on Canvas first, and then we'll add some additional information to it. Okay, so question number 1 says the chemical formula for water is H2O. We should all know that. That's an easy one. Okay, the type of chemical bond that causes hydrogen and oxygen to form a water molecule. The specific type of bond that causes water or hydrogen and oxygen to join together to form a water molecule. Anybody got an idea? I heard hydrogen bond, but that's not it. Polar covalent bond.
I just said polar.
A polar covalent bond. So number 3. Number 3, the actual boiling point of water in Celsius and in Fahrenheit. So let's start with Celsius first. 100 degrees Celsius. What's the boiling point in Fahrenheit? 212 degrees Fahrenheit. 4, the term for the ability of water to creep up tiny tubes against gravity.
Capillary action.
Capillary action.
Were these repetitive?
Very much so.
Yeah, because I was like, hopefully they not. I mean, they are, because I put a lot of the same answers.
All right, number 5, the property of a substance like water to be attracted to itself. When something's attracted to itself, it's called what? Cohesion.
I thought that was just in water, though.
No. So, like, a good analogy for cohesion using football is you want your offensive line to be a cohesive unit, meaning they stick together, they work together, they know what's going on. A lot of times people will say that, or you're all on the same page, you know what's going on.
I'm adhesive because I'm taking to the ball.
Property of a substance like water to be attracted to materials that are different. That's adhesion. That's adhesion. Okay, 7, the actual freezing point of water in Celsius and in Fahrenheit. What's it in Celsius? 0 degrees C, and then Fahrenheit it's 32 degrees Fahrenheit. 8, the skin-like quality of water that causes like a film. It's called what? surface tension. Okay. Surface tension. What's the property that causes surface tension?
Cohesion, I think.
Yeah, it's cohesion. Surface tension is the property. Cohesion is what causes it. All right, number 9. Property of water that causes it to creep up tiny tubes. Capillary action. Now, what properties of water cause capillary action? It's kind of a bonus. So what causes the water to stick to the tube? Say it again, Gideon. That's adhesion. What's grabbing the other water molecules and saying, come on guys, go with me? Cohesion. So adhesion causes it to stick to the tube. Cohesion pulls the rest of the water along with it for the ride. 10. Property of water that causes it to flow together in a stream. Property of water that allows it to absorb a great deal of heat before it changes physical state. High heat capacity. You may also hear that called a high heat of vaporization. But we'll say high heat capacity. High heat capacity. Meaning that water can absorb large amounts of heat energy before it actually changes temperature. Think back to the lab when we watched that one video. It had the beaker of oil and it also had the beaker of water. Okay, y'all remember that? And they were both in a beaker over a Bunsen burner. It had a temperature. It had a thermometer in them. Okay, in the same amount of time, the oil heated up to 1,000 degrees. Y'all remember what the water only heated up to? It was like 500, right? So they absorbed the same amount of heat energy, but water, the temperature of the water was only half as much as the oil because it's absorbed the energy before it actually changed temperature. All right, 11. Property of water that causes it to flow together in a stream. Cohesion. 12. Property of water that causes it to form beads at the surface because the molecules pull together due to their strong attractive forces. That is also cohesion. You notice cohesion is kind of a big deal, right?
Yeah. Very much so.
13. Term for the specific bond that causes different water molecules to bond together. Yeah, those are hydrogen bonds. I'm going to draw that out in just a second. Hydrogen bonds. 14. Property that causes solid water to float on top of liquid water. Its density, or let's just say less dense as a what? It's less dense as a solid. Being that when it goes to its solid form, it's less dense as liquid form. Term for water that is solid. Frozen. It is ice. Had somebody last period that blew their mind. They're like, I got all of them, but number 15. I can't remember what it was called when water was frozen. I'm like, ice? And they're like,
I said frozen.
and they said this defeated look on their
I
face.
said grilled cheese.
Shh. All right, 16. Property of water that helps it maintain body temperature for living things.
I couldn't figure this one out.
That's heat capacity, high heat
I
capacity.
got it, man. Oh, what's that? Oh.
That's why your body temperature doesn't really change even if it's hot or cold outside. Okay, that all the water in your body helps maintain that constant temperature. 17. Property of water that allows it to transport many different dissolved substances. That's the universal solvent. Universal solvent. 18. Property of water that allows sweating to help a body cool. So it's high heat capacity, or we could also say high heat of vaporization. What that means is not only does water have a high heat capacity, meaning that it takes a large amount of energy to change the temperature of water 1 degree Celsius. High heat of vaporization means it takes a large amount of heat energy to actually break hydrogen bonds and go from liquid water to water vapor. Does that make sense? So when you sweat, okay, that's liquid water on your skin, right? You know, you fan it and it cools you off. What's happening is that as that water is getting warm and it's evaporating off your skin, it's taking a large amount of heat with it, and that's what's cooling you off. That's actually what does the cooling. All right, 19. Property of water that protects aquatic organisms from rapid temperature change. High heat capacity. High heat capacity. 20. Property that allows blood to transport dissolved substances to cells in the body. Okay, we just said it a second ago. Universal solvent. Meaning that it's able to dissolve stuff and transport throughout your body. 21. Property that allows small insects to walk on water.
I need some lunch money. What's up?
22. Property that causes water to beat up on the surface of leaves. Cohesion.
Yeah, and cohesion. The way you said it.
Cohesion and adhesion.
Not necessarily, because if it was adhesion, it would spread out over the surface of the leaf. What's actually causing it to stay in the bead is cohesion. All right. 23. Term that refers to uneven distribution of charge within a water molecule. There are opposite ends of the molecule that have a positive and negative charge. Or we can. It is a polar covalent bond, but let's just call it a polar molecule. Polar molecule, meaning that it has one end that's positive, one end that is negative. Even though overall the charge is even, it's neutral, but because of an uneven sharing of electrons, that's what happens. Property of water that causes it to stick to tubes within the body of plants and animals.
Adhesion.
25. Property of water that allows aquatic organisms to remain alive when temperatures are below freezing for weeks. High heat capacity. (26) What property of water allows for photosynthesis to occur even in aquatic environments, even in the absence of plants? Transparency. Okay, so what that means is water is able to go through, or sunlight's able to penetrate water, and photosynthesis is still able to occur underwater. 27. What are the organisms found? What organisms are the foundations of all aquatic food chains? It is plankton, but specifically phytoplankton. Okay, and you can remember this because the phyto means light. So these are the producers, light. They need light in order to produce food. Phytoplankton, they're like plants, basically. Microscopic plants. Where does most of the Earth's food and oxygen come from? Plants. What's the most important product of photosynthesis? To us, it's oxygen. You could argue, okay, because look, here's the equation for photosynthesis. You take water, and this is not the balanced equation, plus carbon dioxide, and you're going to yield glucose plus oxygen. Now, okay, to us, yes, oxygen is important. We have to have it to breathe, but you could argue that glucose would be the most important product and that oxygen is just a waste. But if we look at cellular respiration, that's oxygen plus glucose. Oh, I'm sorry, I didn't write light right there. It has sunlight. Oxygen plus glucose is going to yield carbon dioxide plus water plus ATP, which is energy. Okay, so that's how our body breaks down food, right? When you take in food, it breaks it down through cellular respiration. So you could argue that to us, ATP is the most important product of cellular respiration. But what do plants have to have in order to make glucose? Plants have to have carbon dioxide, right? Carbon dioxide is our waste product because every time you exhale, you're giving off carbon dioxide. You ever heard the expression, one man's trash is another man's? Guess what? Our trash, this oxygen right here, our trash, carbon dioxide, is the CO2 needed to make glucose. Our oxygen, photosynthesis is oxygen is what we have to breathe and be able to break down our food. So it's kind of a cycle. Okay, let's take a look at the next page. Skip around on some of these. All right, so it says, what properties of water cause it to be an excellent substance? Hey, guess what? Why doesn't water dissolve oil? Water's polar. Oil is non-polar. Okay, why is water credited with allowing organisms to maintain your body temperature? That goes back to high what? Heat capacity. Number 4, explain specifically what causes water to be the best solvent for most things. So it dissolves polar substances, ionic and ionic compounds. Draw a water molecule. So I'm going to have to have some space for these two. Don't worry about number 7. So I'm going to do number 5 and number 6 together. Draw a water molecule, label the positions for the covalent bonds as well as areas of positive and negative charge. And then I'm going to draw 3 water molecules, label the position where hydrogen bonds and covalent bonds occur, and orient them correctly. So let me move this worksheet out of the way. Undo that. Okay, so a water molecule is going to look like this. We're going to have, that's oxygen. Here are my 2 hydrogens. Then we have a bond in between them. Okay, so what are these bonds called? Okay, both of these are polar covalent bonds. Now, because it's polar, that means that my hydrogens up here are going to have a partial positive charge and my oxygen is going to have a partial negative charge. Y'all with me so far? Okay, so let's draw a couple other water molecules. So, now if I wanted to draw another water molecule by this, not my best water molecule, but it'll work. Okay, how are these attracted? There's going to be an attraction between the negative oxygen and the positive hydrogen right here. And this is what we call a what? Hydrogen bond. Okay, that is a hydrogen bond. So if I want to draw even more, so there's a hydrogen bond, there's a hydrogen bond, there's a hydrogen bond. So how many water molecules are bonded to this one in the center? 4. And you can just keep building and building upon this, right? So are hydrogen bonds weak or strong bonds? Hydrogen bond, a single hydrogen bond by itself is weak. But if you put a bunch of them together, they are, there you go. It's like Jesus loves me. He is weak, but they are strong. Ha, get it? I thought it was funny. Ruth is not amused. Any questions about that? All right, let's talk about some other stuff you need to know for this test. Let's talk about the pH scale. So it starts with this equation. Okay, it starts with our dissociation of water equation, meaning that water can break down, a water molecule right here can break down into its 2 ions, a hydrogen, or sometimes, what's another name for that? Hydronium, or a hydroxide ion. And these 2 ions can just as easily go back and form water. Now, so let's draw out the pH scale. pH scale goes from what to what number-wise? 0 to 14. What's right here in the middle? 7. What's the only substance we know to be 7?
Water.
Pure water. So what is 0 to 7? Acids. What's 7 to 14? Bases. Okay. Let's talk about ion concentration for a second. So at 7, hydrogen ions equal hydroxide ions. If we have bases, which ion do we have more of? I'm sorry, acids. Which one do we have is greater? Hydronium or hydrogen are greater than hydroxide. And over here, bases, hydroxide is greater than hydrogen. So where are my strong acids and bases at? The extreme ends, right? So this is strong. This is strong. Weak. Sauce. All right. What about the bonds between them?
Did you just say sauce?
Yeah. Okay. Which one has strong bonds? The weak acids and bases or the strong acids and bases? So we have strong bonds here in the middle because it wants to be more like what?
Water.
Wants to be like water. And then over here we have weak bonds on both ends because they want to break down into their ions. Any questions about that? Let's talk neutralization reaction real quick. You're going to have a question just like this. So say I have a okay, so let's label that. Acid plus base yields salt plus water. Everything on this side is called the what? Called the what? Reactants. Everything over here on the right side is called the products. Okay, buffers. We did not talk about a buffer. A buffer is a substance, right up here, that prevents a sudden sharp change in pH. Okay, your stomach has buffers, so when things that are acidic get in there, it doesn't neutralize your stomach acid. Or things that are very basic, it won't neutralize your stomach acid. Trying to think anything else that we need to go over that's on this. Anybody got any questions about anything? Okay, I'm going to load this video on YouTube here in a little bit.
What's it gonna be titled?
I don't know. I'll put a link on Canvas, though, to get to it. Study tonight. Make sure you know what acids and bases are, what their pH is, how they're used in the body, what are the properties of water, to be able to describe the properties of water. Any questions?